This video we will discuss the question of CSIR-NET and question ID is 379. Question is, let V be a vector space of polynomial fx comma y belongs to rx comma y with total degree less than 3. Note this point, that is total degree less than 3, and let t v to v be a linear transformation given by t is equals to curl upon curl x. And question is, which of the following statement are correct? And this question is from part C. Options are nullity of t is at least 3, and rank of t is at least 4, and the rank of t is at least 3, and t is invertible. From given question, V be a vector space of polynomials, that is fx comma y, where fx comma y belongs to rx comma y with total degree less than 3. And now in general, if fx comma y belongs to V, then this fx comma y is equals to a plus bx plus cy plus dx square plus ey square plus fx comma y, because total degree less than 3 means degree either 0, degree either 1, and degree either 2. It's combination of 0, 1, 2, that is this polynomial in general, where this a, b, c, d, e, f are coefficient of this polynomial which belongs to set of real number. Now for this vector space, dimension of this vector space is 6, and basis set of for this vector space is 1 comma x comma y comma x square comma y square comma xy. Now for this question we use rank nullity theorem, that is dimension of V is equals to nullity of T plus rank of T, where nullity of T means dimension of null space of T, and rank of T means dimension of range space of T, where T is a linear transformation. Now for simplicity, we use the concept of a null space here, null space of linear transformation. We know that if a polynomial that is a element belongs to null space of T, this implies that T of that element, that is T of f, is equals to 0 element. For this vector space, 0 element means 0 plus 0x plus 0y plus 0x square plus 0y square plus 0x comma y. And in this question, t is equals to curl upon curl x. This implies that curl upon curl x of f is equals to 0 element. We know that in general f is equals to a plus bx plus cy plus dx square plus ey square plus fx comma y, where this coefficient belongs to r. This means using a partial derivative with respect to x, this is equals to b plus 2dx plus fy is equals to 0 element, and we know that 0 element is in this form. Comparing coefficient on both sides, comparing coefficient on both sides, we get b is equals to 0, 2d is equals to 0, and f is equals to 0. In a set of real number, if 2d is equals to 0, this implies that d is equals to 0, that is b is equals to 0, d 0, and f 0. For this general polynomial, if this belongs to null space, it's a 3 entries, that is b, d, and f are 0 in general. This implies that f is equals to a plus cy plus ey square. This element, that is this polynomial in general, belongs to null space of T, and dimension of this null space is equals to 3, because it have 3 free entries, a free coefficient, that is dimension of this is equals to 3. Now using rank theorem, that is dimension of V is equals to nullity of T plus rank of T. This implies that 6 is equals to 3 plus rank of T, that is rank of T is equals to 3. Now come to options. From the previous discussion we have rank of T is equals to 3 and nullity of T is equals to 3, and this implies that option A is correct, option B incorrect, option C is correct. Now T is invertible. For option D, as we know that a linear transformation, T is invertible if and only if T is injective plus surjective. Now T is injective means nullity of T is equals to 0, but for this question we have nullity of T is equals to 3. This implies that T is not invertible, that is option D is incorrect. So for this question, option A and C is correct, and option B and D are incorrect.